All right, let's get right into it. Today we're taking a deep dive into React 2 Shell, a vulnerability so critical it didn't just rattle the web development community, it basically triggered a full-on meltdown. So first, let's just establish the stakes here. This thing was given a CVSS score of 10.0, a perfect 10. For anyone who doesn't live and breathe this stuff, that is literally the highest, most critical severity score possible. It's what you call a perfect vulnerability, and it means a complete system takeover is possible with zero effort from a user. It absolutely does not get more serious than this. You know, this quote from one of the technical write-ups just hits the nail on the head. React 2 Shell wasn't just some little bug in the code, no. It was a fundamental flaw that was born from the very way we're building the modern web now. It was like a bill for all our rapid innovation suddenly coming due. So, to really get our heads around how this all went down, let's treat it like a digital heist movie. We're going to break down exactly how this perfect cybercrime was planned out, blueprinted, and then, of course, executed.
Okay, so what is React 2 Shell really? Well, at its core, it's what we call an unauthenticated remote code execution vulnerability, or RCE for short. In plain English, that means an attacker, any attacker, anywhere in the world, can run any code they want on your server. And they don't need a username, they don't need a password, nothing. It's literally like having a master key that unlocks every door in the building.
And who had the bad locks? Well, that's the really scary part. This wasn't some dusty old library nobody uses. The flaw was right there in the core of super popular modern frameworks like Next.js. So if you were being a good developer and using the latest and greatest tools, chances are you were exposed from the moment you started your project, right out of the box.
All right, let's look at the blueprint. How on earth did the very architecture that developers absolutely loved for being so powerful and flexible, how did it become the blueprint for this total disaster?
Well, it all comes down to this massive shift in web architecture. In the old days, a server would just send a fully built HTML page to your browser. Simple. But the new way, with things like React Server Components, is way different. Now, the server sends a description of the user interface, not the final HTML. And to make that work, it needed a brand new, specialized way to communicate. And that new communication method is called the flight protocol. Just think of it like a super high-speed delivery system for this new architecture. It was designed to be incredibly powerful. Yeah, but it was built on this foundation of, well, dangerous trust. It just assumed that the data it was getting would always be friendly.
And that trust brings us right to the heart of the heist, forging the master key. How did attackers manage to turn a simple feature of this new flight protocol into a weapon that could blow the doors off the entire server?
They used a technique called prototype pollution. Now, it sounds complicated, but here's the gist. In JavaScript, almost every object inherits its basic properties from a master blueprint, called a prototype. This attack lets a hacker scribble something malicious onto that master blueprint. And once the well is poisoned like that, pretty much every other object in the entire application inherits that same malicious code.
And here's how they pulled it off in just 4 steps. First, the attacker sends their poison pill message. Second, the server's code gets confused and completely misreads the instructions. Third, that confusion is the opening they need. It lets them trick the parser into giving them access to a kind of master function deep inside JavaScript itself. And boom, step 4, the attacker's code runs with full privileges. It's game over.
And here's a really fascinating little detail. The whole exploit relied on what's being called a promise masquerade. It basically disguised the malicious code to look like a perfectly normal piece of data the server was expecting. So by the time the server realized it wasn't legit, it was already too late. It was running the attacker's commands. The payload was a wolf in sheep's clothing.
So, with the master key forged and the vault door blown wide open, what happened next was, well, it was inevitable. A global cybercrime spree, with threat actors from all over the world racing to exploit this flaw.
And the attackers were, a really diverse bunch. We saw state-sponsored groups using it for espionage. We saw cybercriminal syndicates deploying crypto miners to steal computer power. We even saw these guys called initial access brokers, whose whole job is just to break into servers and then sell that access to other criminals.
And they came ready for a fight with a whole arsenal of malware. We're talking tools like Minocat to tunnel past firewalls, Hisonic to set up secret command and control channels, and of course the infamous XMRI, a program designed to hijack a server's CPU to mine cryptocurrency for them. But what's really crucial to understand here is the speed and the automation. Attackers weren't poking around looking for valuable stuff. No, They deployed these secret hunter scripts that could automatically scan for and steal API keys, database passwords, and cloud credentials all within seconds of the first break-in.
Okay, so that's the crime scene. Now for the final act, locking down the vault. How do you defend against a heist this devastating? And, more importantly, how do you clean up the aftermath?
And this brings us to the most critical question for any organization that got hit by this. After a full server takeover, an RCE of this magnitude, is just patching the hole really enough?
The answer from security experts was a loud, unambiguous no. The only truly safe response is what they call the nuke and pave protocol. You have to assume the attacker has left traps and backdoors everywhere. That means you isolate the server, you completely destroy it, you revoke every single secret key or password it ever had access to, and only then do you rebuild a fresh server from a patched, clean source.
So here's the actionable advice. These are the specific patched versions of React and Next.js that are safe. If you're running anything older than these with the app router, you need to update immediately. There are even automated tools you can run to scan your project and help you apply the right fixes.
Ultimately, the entire React to Shell saga can be summed up by this one powerful lesson from the security researchers. The assumption that a serializer will only ever receive good data is a fatal error. The system was simply designed with a level of trust that attackers were just all too happy to exploit.
Which kind of leaves us with a final, pretty unsettling question. This whole vulnerability was born out of our tools becoming more and more complex. So, as our digital world continues to get even more intricate and interconnected, you have to wonder, how many more of these fatal errors are just sitting out there, waiting to be found?